When scientists first began comparing data on 3I Atlas's early state, it became clear that its current activity was merely the tip of a story that began much earlier than anyone had imagined. For millions, perhaps tens of millions of years, 3I Atlas remained in a state of deep cosmic hibernation, completely encased in a multi-layered shell of ancient ice formed in distant regions of interstellar space, where temperatures drop to levels where even the residual heat of the past becomes ineffective. This icy shell was so massive that it could withstand micrometeorite impacts in the intense cold of space, turning the object into a kind of frozen sarcophagus, an ideal repository for any material hidden within. Many experts believe that Atlas originally formed in one of the interstellar clouds, where large fragments of water ice combine with metallic dust and carbonaceous compounds to create large, comet-like bodies. But what sets Atlas apart from ordinary interstellar ice flows is that its shell density was too high to be explained solely by a natural process. If we recalculate the object's mass per unit surface area, the ice layer would have been not just thick, but incredibly uniform, as if it had formed in conditions devoid of temperature fluctuations, turbulence, and external influences. This led some scientists to speculate that Atlas's existence in these conditions may not have been a coincidence, but rather the result of its long-term presence in a region where the external environment was nearly ideal for the formation of a protective layer. However, as our understanding of Atlas grew, it became clear that the icy crust was not simply a consequence of its ancient origin. It was an absorbing system built around an internal reservoir. The spectral signatures detected indicate that beneath Atlas's centuries-old ice lies a vast amount of water, trapped in closed cavities. What's important is that the water in these cavities isn't simply frozen, it's in a state characteristic of extremely long-term compression under pressure. This state of water can only be maintained by the presence of a massive shell that maintains the internal pressure and prevents the water from expanding into ice. This strange phenomenon explains the current water emissions into space. If large closed reservoirs of liquid exist within the object, gradually absorbing heat, whether from rays passing through interstellar space or from internal processes, the pressure within them should increase. But Atlas isn't disintegrating under this pressure. On the contrary, it's releasing it, as if releasing accumulated energy. This explains the rhythmic nature of the emissions. When the pressure reaches a critical level, one of the ancient cracks or flexible zones of the shell opens for a split second, allowing a jet of water to escape into space. But something else is far more interesting. These emissions occur not chaotically, as in a typical comet, but with almost mathematical precision. For this to happen, the internal reservoirs must be systematically arranged, not randomly. This leads researchers to the theory that Atlas was subjected to prolonged external influences that not only shaped its frozen shell, but also altered its internal structure. Perhaps Atlas once passed too close to a massive stellar object, a neutron star, pulsar, or even a nebula, where electromagnetic fields could have rearranged its matter, creating closed pockets of liquid within. If this scenario is correct, then Atlas is not just a comet, but a unique interstellar container, within which a slow but continuous evolution of matter is taking place. For millions of years, it remained completely frozen, holding within it vast masses of water, gases, and perhaps even more exotic compounds. But as it passed through certain regions of our galaxy, it encountered weak energy currents that gradually eroded its inner layers, creating pressure that now manifests as water jets. Interestingly, Atlas's current activity appears to be the first stage of a process that was once completely normal in its life. Atlas may be a fragment of a larger object that was destroyed in the distant past. Its original core may have been part of a closed system, designed to store matter or information under an icy shield. Over time, this system collapsed, but its remnants continue to function according to ancient laws of internal architecture. It is hypothesized that Atlas experienced several heating periods in the past, each of which triggered processes similar to those we observe today. During these periods, the object temporarily transitioned from a state of utter cold to a phase of activity, shedding excess water and gas. It then cooled again and entered a multi-million-year slumber until circumstances intervened. We waited for it again. But what's extremely strange is that Atlas's current period of activity appears to be more than just a consequence of solar heating. Too many processes coincide perfectly. Water emissions occur as the object passes through zones of increased interstellar dust density. Its size increases during phases consistent with internal stretching patterns. Changes in the tail are a response to pressure from within, not just from without. All of this leads to the idea that Atlas doesn't simply store water, it works with it. The water inside Atlas isn't simply a frozen ancient liquid. It's part of a complex system that maintains the object's balance. And the current emissions are not a coincidence, but the result of the accumulation of processes that began long before the emergence of humanity, possibly long before Earth emerged as a planet. From the moment telescopes first captured the strange crystalline texture of 3I Atlas, scientists suspected it was unlike any comet ever recorded. But only after high-precision spectral scans mapped the molecular composition of its icy crust did an even more extraordinary theory begin to take shape. A theory suggesting that Atlas was not born in a lonely cloud of dust like other interstellar wanderers, but was once a piece of a complete frozen world, a planet-sized body covered in ancient oceans locked beneath a global sheet of ice thicker than any glacier found on Earth. The chemical fingerprints embedded in its frozen shell differed radically from those of local comets. The ratio of deuterium to hydrogen, the oxygen isotopes, even the microscopic mineral grains trapped between layers of ice pointed to a geological history impossible for a loose comet nucleus to possess. These were signatures of stratification, high-pressure freeze cycles, and deep planetary layering, conditions that arise only on a fully formed planet orbiting a distant star. This idea might have been dismissed as science fiction, if not for the strange uniformity in the object's internal density map. Radar reflections revealed compacted regions of ice and rock pressed tightly together, as though enormous forces once pushed and compressed them over millions of years. Such pressures do not exist inside typical comets. They form in the cold, open void of the outer stellar nurseries, never experiencing the titanic internal shaping that planetary bodies endure. The evidence forced astronomers to reconsider all prior assumptions. 3I Atlas might not merely be a traveler. It might be the last surviving shard of a shattered exoplanet that was violently destroyed in an ancient catastrophe. The reconstruction of that catastrophe reads like the opening chapter of a cosmic tragedy. Simulations conducted by planetary physicists suggest that billions of years ago, this frozen world orbited quietly around its star, accumulating thick layers of global ice, while internal geothermal heat kept subsurface oceans alive. Then something enormous, perhaps a rogue asteroid the size of a small moon, or even the gravitational recoil from a nearby stellar explosion, smashed into the planet with unimaginable force. Unlike Earth, whose molten core allows it to absorb some impacts, this frozen world was brittle, crystalline, and rigid. The strike caused the entire planetary crust to fracture outward in colossal sheets, sending titanic fragments flying across space like shattered glass propelled by stellar gravity. One of those fragments, loaded with trapped ancient oceans and solidified minerals, was torn free with enough velocity to leave its home system entirely. That fragment is what we now follow across our skies as 3I Atlas. For ages it drifted through the interstellar darkness, insulated by extreme cold that kept its internal oceans frozen solid and preserved the alien geological patterns embedded in its crust. Over millions of years, the vacuum sculpted it. Micrometeorites chipped away at its surface, and the frost accumulated layer upon layer until the entire fragment resembled a drifting iceberg the size of a mountain. The images you provided, showing thick icicles, fractured ridges, glowing fissures, and crystallized overhangs, match perfectly with what such a world fragment would look like after eons in the void. A frozen relic carrying the memory of an extinct planet. But what is most remarkable is what happened when this icy monolith began to warm during its approach to our sun. Variations in solar radiation caused internal pressure pockets to awaken deep beneath the crust, melting some of the ancient ice into liquid and heating volatile gases trapped since the age when its parent world still existed. These pockets eventually erupted outward through cracks and weakened fault lines, releasing jets of vapor that extended thousands of kilometers into space. Astronomers observed these eruptions and initially classified them as standard comet outgassing, until they noticed patterns in the jets that defied randomness entirely. Unlike typical comets, whose water plumes burst irregularly based on surface heating, 3I Atlas exhibited rhythmic intervals. The jets pulsed in repeating sequences, almost like synchronized breaths coming from a deep interior. Some eruptions aligned too precisely with internal temperature changes, suggesting layers of ice arranged in structured strata rather than chaotic deposits. Others emerged from fissures that seemed too symmetrical to be natural. And as Atlas crossed various thermal zones, the sequences shifted in ways that appeared not chaotic, but adaptive, almost as if the object were responding to environmental changes. This raised an unnerving question among several research teams. If this truly is a fragment of a frozen planet, could subsurface processes, ancient residual heat, trapped energy pockets, or even crystallized tectonic layers still be active after billions of years? The idea seems impossible, yet the behavior of Atlas keeps straining the limits of what we consider natural. The glowing seams in the images, the strangely geometric fractures, and the directed jets all hint at an internal structure that may be more complex than anyone dared imagine. And so the picture grows clearer and more mysterious at the same time. Before becoming the luminous traveler we see today, 3I Atlas was part of a colossal frozen world shattered in an apocalyptic impact. It drifted through interstellar night for countless ages, its ancient oceans locked beneath an icy shell. Now, warmed by our sun and shedding those ancient waters into the vacuum, it reveals the last remnants of its planetary origin. Fragments of history frozen in blue fissures and erupting geysers that whisper of a world long destroyed. But beneath all of this lies a deeper question scientists can no longer ignore. If Atlas carries the memory of a lost planet, what else might it carry within its fractured core? The answer, whatever it is, will shape the next part of the story. As 3I/Atlas moved deeper into the inner regions of our solar system, its transformation became impossible for scientists to ignore. The once still, frozen crust began to exhibit dynamic behavior that defied every logical expectation for a simple interstellar ice fragment. High-resolution thermal imaging detected not only surface warming, which was expected as the sun's radiation intensified, but distinct zones of internal heat that shifted and expanded in ways far more complex than passive melting. These heat signatures did not diffuse uniformly. Instead, they migrated beneath the surface like moving islands of energy, suggesting a core reacting to its surroundings. The more researchers analyzed these patterns, the more clear it became. The interior of Atlas was not simply thawing, it was awakening. What startled researchers most was the discovery that these heat zones correlated directly with the locations from which the most powerful water plumes erupted. Instead of melting randomly, the interior seemed to funnel its accumulated liquid toward designated exit points, creating towering jets of vapor that burst into space with startling precision. Spectroscopes, capturing this vapor, noticed something stranger still. The chemical composition differed from plume to plume. Some jets contained almost pure H2O ice, while others showed traces of ammonia, methane, and rare crystalline salts found only in deep ocean environments on planetary bodies. It was almost as if Atlas were releasing layers of its ancient world in chronological sequence, exposing the geological and hydrological history of the planet it once belonged to. Because of this, researchers began referring to Atlas as a chronological geyser, a term coined by an ESA geochemist to describe the way each plume seemed to be ejecting a different chapter of its lost planet's past. The outermost layers contained simple ice and dust, remnants of the world's upper crust. But deeper layers produced vapor enriched with exotic compounds, minerals forged under extreme pressure, and even large crystalline ice structures that resembled frozen ocean sediments. These were not the chaotic outgassings of a comet. They were the organized release of a world's buried memory. This phenomenon raised uncomfortable questions in the scientific community. Why were the eruptions so orderly? Why did they align with internal heat pockets as though directed by an underlying structure? And most unsettling of all, why did several of the cracks from which the water escaped appear to widen symmetrically, as if following predetermined fracture lines rather than random breaks caused by solar heating. Engineers studying these fissures noted angles and patterns eerily similar to geometric planes, reminding them of tectonic grid lines rather than natural ice fractures. Then came the most controversial observation. Several of the largest plumes exhibited a faint electromagnetic pulse before erupting. Normally, the interaction of sunlight with ice sublimation produces no such signal. But instruments detected microsecond bursts of EM radiation that preceded every major outgassing event, almost like an internal ignition switch being activated. The bursts were too consistent to be dismissed as coincidence. NASA's internal report on the anomaly leaked within days, sparking debates that escalated into global fascination. Was this simply an unusual physical reaction occurring within the frozen core? Perhaps a legacy of the planet's ancient magnetic field trapped in solid form? Or was something inside Atlas generating these pulses intentionally? The notion of an organized system buried under kilometers of ice, whether natural or artificial, was too provocative to ignore. Yet the most stunning discovery came when the James Webb Space Telescope captured high-detail infrared imagery during one of Atlas's closest passes. Beneath the translucent frost, analysts spotted a recurring hexagonal pattern, faint but unmistakable. The hexagonal arrangement hinted at structural regularity, something reminiscent of crystallized mineral lattices, yes, but also uncannily similar to engineered architecture when viewed at large scale. Some scientists argued it was simply the product of high-pressure ice polymorphs forming geometric patches. Others insisted the scale was too vast and too aligned to be natural. If this fragment truly came from a frozen planet shattered by an ancient cataclysm, then perhaps the hexagonal formations were once part of that planet's internal crust, the rigid, geometric layers formed by tectonic compression. Still, conspiracy surfaced. Could these patterns belong to something embedded deep within the planet, long before it shattered? Speculation intensified when astronomers observed irregular flashes from deep within the core, tiny pulses of blue light that flickered through cracks in the ice, captured by long-exposure imaging. These were dismissed initially as cosmic rays striking the surface, but when the flashes repeated in consistent intervals, synchronized with the EM bursts detected before water eruptions, the coincidence became impossible to ignore. Something inside Atlas was producing light, or reflecting it. The idea that Atlas might house a remnant of alien technology is considered fringe in mainstream institutions, but several physicists have noted that the combination of synchronized jets, electromagnetic pulses, geometric structures, and internal illumination cannot be easily explained by standard astrophysical models. And if its origin truly is a frozen exoplanet with subsurface oceans, one question looms over every discussion. Could something have existed within that planet before the catastrophic impact? Whether biological, mechanical, or geological in nature, the internal mechanisms driving Atlas are unlike anything scientists have ever seen. As it continues its journey through our solar system, shedding water, revealing fractured crystalline layers, and pulsing with enigmatic energy, it becomes increasingly clear that the story of Atlas is far from over. If anything, it is only now beginning to reveal the deepest secrets buried in the heart of a long-lost world.